All right, so today's uh, lesson is on the vertex of a parabola. So we are covering briefly this week quadratic equations, graphed basically, graphing quadratic equations, and they form a parabola. And finding the vertex is really important, and this is something that you're going to have to do when you go into college algebra as well. It's going to be very important in that class. It's a skill that's important when you're in calculus because you're usually finding maximums and minimums. It's very important in business. So that's what we're doing today. So a quadratic equation in two variables. So we've done so far things with one variable with just x. So we've had ax squared plus bx plus c. We have factored these, and then we set that equal to 0 and we solved. If you set it equal to a second variable, y, you now have something that you can graph, and it forms a parabola. So it's basically, it looks like an arch or a U, however you want to look at it. It depends on some of the, it could look more U-shaped versus arch-shaped depending on the factors, but that is what the shape of a parabola is. And so parabolas can go in two directions. Essentially, you're opening up where your leading coefficient, and let me write standard form again. So it's y equals ax squared plus bx plus c. So your leading coefficient is a, the number in front of your highest term. That's why it's called leading, because it's the first thing you see. So if that is a positive number, then it opens up. Think of it, if you're positive, you're smiling. If it's a negative number, it opens down, you're frowning. So literally the sign of that number determines if your shape is a smile or a frown for your parabola, which is a really nice way to think about it. So notice that the parabola is sort of symmetric. You can form a mirror image. And so that point where it changes direction, where it's sort of at the center, is called the vertex. That point where it goes from one direction to the other and it kind of starts turning back on itself. And that is usually the minimum or the maximum point, depending on if it's opening up or opening down. So if it's opening up, it's a minimum because it's the lowest point. So in this picture, it's a minimum. But if it's going the other direction, if it looks like a frown, it's going to be the maximum. And so the vertex is an ordered pair. You have an x value and a y value. The x value we call h, and the y value we call k. So these are just special letters, h and k, that we use to specifically reference the vertex. And we've got a formula to find the x value, which is h. It is negative b over 2a, which is actually part of the quadratic formula. If you recall the quadratic formula, you have negative b, and then you have plus or minus a whole bunch of stuff, and then it's over 2a. It's like you took just the first part of it. And so that gives you your x value of the vertex. You just use that formula. And then to get the y value, k, you plug your x into the equation, and then that will give you y. So that's how you find your vertex. And then you can see that, of course, if you draw a vertical line through the vertex, you can see where the reflection is, and that's called the axis of symmetry because it's the same on each side of that. And so that is actually an equation of a line. It gives you a vertical line, and the formula for that is just x equals h. So you have to find h first, and then you write an equation, x equals whatever that number is. And that gives you the axis of symmetry. So for the rest of the slides, we're just going to go through several examples of finding the vertex. And yes, there will be word problems so that you see, where are these used in real life? Why is this handy? So first, we're just going to practice the formula. So we're going to find the vertex for these two parabolas. And you know they are parabolas because they are quadratic. It's something squared. So if your highest exponent is 2, it's going to be quadratic. It's going to give you a parabola when graphed. So going back to our formula, it's h comma k, and h is equal to negative b over 2a, and then you plug that into your equation. So our first equation here, we have y equals x squared minus 4x minus 4. So if there's no number in front of your variable, you can write it with a 1. So we can rewrite this as 1x squared. And then if it helps, you can put all of your subtraction as adding a negative. So plus negative 4x and then plus negative 4. And that will tell you that a is equal to 1, because a is the number in front of the x squared. B is equal to negative 4. And then C is equal to negative 4 as well. These are the same A, B, and C that we use for factoring with the AC method, and it's the same A, B, and C we use for the quadratic formula. So that should be familiar. So you need to identify your A, B, and C. We actually don't need C at all when we're determining the x value, because the formula is just negative b over 2a. So we will start by finding h. So the formula is negative b over 2a. So b is negative 4. So I'm going to have a negative, and then I'm going to replace b with negative 4. So those are going to give me a positive out because it's a negative and then negative 4. And then in the denominator is 2 times a, and a is equal to 1. So now we just simplify this. So we get a positive 4 on top. 2 times 1 is 2. So you get 4 over 2, and that simplifies to 2. So that gives you your x value for your vertex. So that's h. And then you plug in that number for x so that you can get k. So instead of like y equals, I can say k equals, and then instead of x, so it might help. So this is x, and then you can just say, okay, k, that is y, just kind of help you what you're plugging in here. So it's x squared, we're going to use 2, so it's 2 squared, minus 4 times x, so that's going to be times 2, and then minus 4. And then you're going to follow the order of operations here to simplify this. So 2 squared is 4. We have a minus 4 times 2, which is 8, and then a minus 4. And you can just put this all on your calculator going left to right. 4 minus 8, and then minus 4 again, and you're going to get negative 8 out. So once you find your h and then your k, your answer is an ordered pair. H comes first, k comes next. And that is your vertex. So your answer is an ordered pair because it's a location on the graph, and the graph has an input and an output value. Now you can verify your answers using graphing. So I mentioned this last week. A really great website is desmos.com. So I'm going to bring that over. Go to graphing calculator. And then what we're going to do is we're going to put in this formula that we have here, x squared minus 4x minus 4. You can type it in with the y. Y equals x squared minus 4x minus 4. Okay, and so you can see it gives us a U-shaped. It's opening up because the x squared has a positive in front of it. And so this is the vertex right here, this lowest point. This is the minimum, and when I hover over it, you can see that it gives us the same value that we found using our formula, 2, negative 8. And so that's a way to check that you did your math right, is by graphing it and then double checking that the number you see on the graph matches what you solved for, assuming that you typed in the correct graph. So let's look at this second example here. We've got y equals 2x squared plus 4x minus 6. So a is 2, b is 4, and c is negative 6. So we're going to do the same thing that we did on the first example. We're going to find h. So it's always good practice to write down the formula first. H equals negative b over 2a. And then plug in your numbers. So b is 4, so this is going to be a negative, and then I plug in 4 over 2 times a, and a in this case is 2. So order of operations, we still have our negative 4 on top. We need to multiply in the denominator. 2 times 2 is 4. And then we simplify. Negative 4 over 4 gives us negative 1. So we've got h. Now we need to find k. And we plug it into our equation for y. So I could, write out the full equation that we're using here. 2x squared plus 4x minus 6. And then we're replacing x with the value we just found for h. So everywhere we see x, we're going to replace it with negative 1. So k equals 2. And then I have to have parentheses here. Negative 1, close the parentheses, and then square. That's really important if you're putting that in your calculator, because if you don't have the parentheses around the negative, it's going to assume the negative is not included. Then plus 4 times negative 1, then minus 6. So negative 1 squared is positive 1. 2 times positive 1 is 2. 4 times negative 1 is negative 4. And then we have negative 6. And so 2 plus negative 4 plus negative 6 is going to give us negative 8. So our vertex is the h value we found, negative 1. And then the y value we found, negative 8, or k, basically. Oops, and I need to write that as an ordered pair, so I must have the parentheses around it. Otherwise, it is not an ordered pair. So, welcome. So before we move on, I do want to graph this equation. So we're going to graph this bottom one to verify. So we've got 2x squared plus 4x minus 6. And then our vertex is the lowest point here. You can see it's negative 1, negative 8. And that matches with what we found with our formula. Okay, so a couple more examples here, and then we'll get into the word problem. So I will rewrite our formula for the vertex. It's hk, which is our symbolism. And then h is equal to negative b over 2a. And then to find k, that's the same thing as the y. So you plug in your h into the formula, and that will give you your y value out. Sometimes instead of h, you'll see people write x equals negative b over 2a. That's completely fine. I'm just making a connection to the letters that we use specifically for the vertex being h and k. So we've got our first parabola here, first quadratic equation. We've got y equals negative x squared plus 4x minus 2. So we have a negative in front of the x squared, which means a is going to be negative 1. So if there's not a number, you assume it's 1. And then we've got b is equal to 4. And we don't really care what c is because we don't need that to find h. We just need b and a. So h is negative b over 2a. So b is 4, so that gives us negative 4 over 2 times a, which is negative 1. So The most common mistake I see people making is using the wrong sign, either forgetting the negative on the top or a negative in the bottom. So it's really important that you use your signs properly, because if you get this wrong answer for H, then you're going to get the wrong answer for K, because you use H to find K. So you want to be very careful when you're finding H. So we have -4 on top, and we get a -2 in the bottom. So the two negatives cancel, and we get a +2 out for H. Now to find K, you plug that into your equation. So we've got -x², and that's going to be -2² plus 4 times 2 minus 2. Since that H is essentially an X value, we plug it in, and then that will give us K, which is a Y value. So 2 squared is 4, but we have a negative in front, so we get -4. 4 times 2 is 8, then -2, and that gives us 2 for our K or Y. So our ordered pair is H comma K. So H is 2, K is 2, and you write it as an ordered pair, so you have to have those parentheses. So our vertex is always an ordered pair. So you get 2 comma 2 here for this parabola. So I'm just going to bring Desmos up so that way we can graph to verify. So in this case, we've got a -x². Oops, I didn't delete everything. -x² plus 4x minus 2. And so this time, because we have a negative in front of the x², it's upside down. So it's basically forming a frown here, and it just goes on. And so our vertex is a +2, 2, which gives us a maximum because it's the highest point here, and then the rest is below it. So our vertex is a maximum at 2 comma 2, which is exactly what we got when we solved. Are there any questions? Okay. Last one here, this is a little tricky because we don't have a middle term. And thank you for asking about my throat. It is almost 100% better. It's still got a little bit coughing, but nowhere as bad as it was last week. So I've still got my water. Yeah, I do sound better. I actually finished my antibiotic today. I got the last dose, and I don't think I'm going to need to do the refill. I think it's good. So this second example, we have y equals 4x² minus 1. And notice that there's no x thing in there. So when you rewrite this, you have 4x². If there's no x term, it says 0. So we've got 4x² plus 0x minus 1. So that tells us that b is equal to 0. And a is equal to 4. So it is possible that you don't have that middle term and you have 0 there instead. So to find the vertex, we start with h equals -b over 2a. And so b is 0, and -0 is the same as +0. So it's just 0 on top. You don't have to write the negative sign because it's 0. And then 2 times 4 goes in the denominator. So this gives us 0 over 8, and 0 on top of a fraction means 0 divided by something, and 0 divided by anything is 0. I see a lot of people actually mess that up, and they'll put like 8 or they'll put 1. So if 0 is on top, your answer is 0. So our h value is 0. This does not mean we don't have a vertex. You always have a vertex. It's just at 0 for your input, your x. So that actually makes it really nice when we're finding k, because we're plugging 0 into our equation. So 0 squared is 0. 0 times 4 is 0. So we just get 0 minus 1, which gives us minus 1. So our vertex is 0, negative 1. So if you get a B that's 0, that is really, really nice because it makes your calculations pretty simple. So just to verify, we have 4x squared minus 1. And so it's a minimum here because the number in front of the x squared is positive, so it's opening up. And then our vertex here is at 0, negative 1. You can see it matches our calculations. So that's the basics, but what you really use this for is word problems, of course. So I've got only two word problems, don't worry. A child kicks a ball into the air, and the height of the ball, y, in feet, can be approximated by y equals negative 16t squared plus 14t plus 3, where t is the number of seconds after the ball was kicked. So they're telling us that t is the input, and instead of using x, we're using t to represent time. So that's your horizontal. And then y is your output, and that is the height of the ball, which is measured in feet. And this equation that they're using is actually a very common equation in physics. So this actually does follow the laws of physics. It's not some equation we made up. But the physics equation, they usually use S. And it's negative 16t squared plus, this is v naught t, that is the velocity at which the thing is hit. So that'd be like 40 feet per second in this case. And then plus s naught, and that the 0 is pronounced naught. It's N-A-U-G-H-T. It's a weird old way to say 0. They would say naught, like, I don't know, like 200 years ago, but it's still stuck around in math. So, and that usually stands for the velocity, like anything at time 0. So v naught means the velocity at time 0. So that's the initial speed of the kick, of the ball, or whatever, when it was kicked. So that's 40 feet per second. And then s naught is the initial height of the ball as soon as you start counting. So that would be at 3 feet. So this kid kicked the ball at 3 feet off the ground. So probably somebody kicked, the ball was coming towards him and he caught it in the air. It's not kicked it off the ground, because it was at the ground, that would be at 0. And I'm going to malign Old English as much as I want, because I'm not an English teacher. But so this is an actual physics equation, and it's generally called the projectile motion equation because it models a projectile, something getting kicked in the air. It works for baseball. It works for even things dropping from a certain height. It's often used for cannons. It can work for even like ballistics. There are some modifications that you can make for angle and things like that, but for the most part, this equation actually models real life. So we've got two things we're doing here. We're finding the maximum height of the ball, and then how long will it take for the ball to reach its maximum height. So when you have a quadratic, if you see find the maximum, that tells you you're finding the vertex. And don't worry about, oh, is that actually the real maximum or not? Because they're not going to tell you to find the maximum if it's actually minimum. So just seeing that word means, oh, I am finding the vertex. And if it says to find the maximum height, height is the output. So this part is asking you to find k. But we need to find h in order to find k. So the second question, how long will it take for the ball to reach its maximum height? That is the input, that's t for time, and that is h. So we actually have to do these two parts in opposite order based off of what they're asking for. So you have to actually sort of pay attention They're like, okay, which variable are they looking for? Because height is y, and that's our k. And then if it says how long, that's our input, which in this case is t. So we will do the second problem first. And so h, negative b over 2a. And a is negative 16. B is 40. That's what's in front of the t. So it doesn't matter if it's an x or a t. It's just whatever's in front of these things. So negative 40 goes on top. And then we have 2 times negative 16. So negative 40 over negative 32. And so this is actually going to give us a fraction. 40 over 32. I'm using my calculator to just do that for me. We're going to get a positive 5/4, or if you write that as a decimal, that's 1.25. Now, generally for real life problems like this, we'll write it as a decimal because you're not going to go up to somebody and say, it took you 5/4 seconds. You're going to say it took 1.25 seconds. So our answer here is 1.25 seconds. So you always want to include your units because it's a real life problem. And you're allowed to use decimals because it's a real life problem. So it took 1.25 seconds for the soccer ball, or we'll just say soccer ball, the ball, to get to the maximum height. Now we want to know how high did it actually go. So now I'm going back to the top part to find k. So we've got negative 16, and then it's t squared. So we're plugging in 1.25 seconds. Then plus 40 times t. So once again, I plug in 1.25. And then plus 3. So definitely are going to need a calculator here. And we'll show more steps here because this is going to be more more calculations here than it would with a whole number. So 1.25 squared, 1.5625. I'm going to do the 40 times 1.25. So that would be plus, that actually comes out to 50 nicely. And then plus 3. Now I'm going to do a negative 16 times 1.5625, negative 25. So we have negative 25 plus 50 plus 3. And that gives us 28. So the units for our height here, it says the height of the ball is in feet. So the maximum height is 28 feet. So if you're asking yourself, well, how do I know if, I did my calculations right, especially with the time? If you get a negative for your time, that means you messed up a sign. Because on a real problem like this, you should have a positive answer for time because we don't go backwards in time. We have not learned how to time travel yet, so we can only go forwards. So that's one way to double check yourself, as if you accidentally get a negative. If you get a negative for your height, that's another indication that you might have messed something up, because while we can go below ground, we can't, kicking a ball is not going, it's not going to have enough force that it can burrow into the ground and go below the level of the ground and go negative, because negative would be like in a hole. So I mean, in a maximum height, you're not going to expect your maximum to be a negative number. That wouldn't make any sense. So with a real world problem, you can check, basically, you better not get any negatives here, because if you get a negative, something went wrong. Are there any questions? Okay. So here's another one. And this, again, this comes from real situations. Actually, this one's for tire pressure, but actually believe it or not, the miles per gallon you get for your car is also parabola or quadratic, because if you, it depends on like your speed. If you're going at a slow speed, you're getting, there's a point where you actually get really low miles per gallon, and then there's like a sweet spot, and then it gets worse again as you get too fast. So, so that's another example of a quadratic, but this one is pressure for a tire. And in the book, there's examples for like sales, and there's examples for all sorts of things, revenues, profit, tons of things. So the pressure X, so our input here is X, in an automobile tire can affect its wear. Both overinflated and underinflated tires can lead to poor performance and poor mileage. For one particular tire, the number of miles that a tire lasts, Y, in thousands, so that's important that these are thousands, that, and they do that so that you don't have to like use really big numbers in your calculations. So they convert it in a way that you can use smaller numbers, and then you just have to remember that these are thousands. But the formula is Y equals negative 0.875 x squared plus 57.25 x minus 900. Where x is the tire pressure in pounds per square inch, which we abbreviate with PSI. So we want to find the tire pressure that will yield the maximum number of miles that a tire will last, and then find the maximum number of miles that a tire will last if the optimal tire pressure is maintained. So that word maximum tells us we're finding the vertex, and it says find the tire pressure. And so tire pressure, it says, is X. So in this case, we're looking for H, because that's the input value here. So it's not out of order. And then it says find the maximum number of miles, and that is Y. So K is the second part. So it's good to kind of write down, well, what am I looking for, and match it up with the variables that they give, so you know which part of the question you need to do first. So in here we can do this in order. So based off of our formula, A is negative 0.875, B is 57.25, and we don't care what C is. We just need to know A and B. So H equals negative B over 2A. So we have a negative, and then B is not negative, so we don't have to worry about that. So that's just going to be a negative 57.25. 2 times A, negative 0.875. So we get negative 57.25 over calculator time. Negative 1.75. So we have two negatives, we're going to get a positive, which makes sense because you should have a positive tire pressure. We have not invented negative pressure yet. Well, negative pressure does exist, but we don't do it in tires. So you divide these, and it comes out to 32, and I have lots of decimal places, so I'm going to just write them all out. 32.713285771. Those are all the decimals that my calculator gives me. And so generally you look at the decimals that they give you originally in the problem. So our first number has 3 decimal places, our second one has 2 decimal places, and you usually choose the least. So we're going to have 2 decimal places. So I want up to the 7-1, and then I'm looking, do I need to round? But the after the 2 decimal places is 4, and so if it's below 5, you don't need to round. So we're going to get 32.71, and so the tire pressure would be 32.71 PSI. And of course it depends on the tire. My tire says it needs to be at 35. There are other tires that need to be at 32. Something like this, they would probably just put 32 on the actual tire versus telling you exactly 32.71. They're not going to say 33 because I don't think I've ever seen them do that. But that's the tire pressure that will get you the maximum number of miles on your tire. So if you kept it at this pressure, you know, you should be good. And yes, temperature matters. When it's cold, the pressure usually decreases, and so then you have to watch that. And then if it's hot weather, it usually increases. And if you're someone that really cares about that mileage, some people actually do take the weather into account and like measure their tire pressure and all that kind of stuff. So that gave us the tire pressure, that gives the maximum number of miles. Second part says to find what is the actual maximum number of miles if you have that tire pressure and and you maintain it the whole time. Perfect world, you can't actually maintain that the whole time, but if you were in a perfect world, what would be the maximum miles? So we have K equals, and then we use our formula. We have negative 0.875. And then we are plugging in 32.71. And I need to remember it's squared because it's x squared here. Plus 57.25 times 32.71. And then minus 900. So I need to square the 32.71 first. So it's negative 0.875. I get 1069.9441. Then I'm going to do 57.25 times 32.71. So I get 1872.6475 and then minus 900. Next line, I need to do the multiplication of negative 0.875 times 1069.9441. Make sure you're typing in everything in your calculator right and you have your decimal places in the right spot. Negative 936.2010.875. And I usually round at the very end. So I'm just writing out my full numbers. I don't round until I'm done. And so then I'm going to put that all in my calculator and hope that I don't make a mistake typing in a number. I got 36.446412. 5. So remember this, it says that y is given in thousands, so this is not 36 miles. This is roughly 36,000 miles. Now if we had, with all the decimal places, we could find the exact number of miles. It would be 36,446 miles roughly. If you wanted the exact number. But for something like this, we could just round our calculated number to a whole number, which would be 36, and then include the units. So we would say 36,000 miles. Whoops, and I'm writing units instead of miles. So, we could find exactly 36,446, but we're just... in real life, they're not going to tell you that number for the miles. They say these tires are good for 36,000 miles or 45,000 miles or things like that. They're rounding. They're not going to give you the exact value. So that's the maximum number of miles, roughly, that these tires will last if you are using that PSI exactly the whole time, which is impossible in real life. But at least it can give you a ballpark estimate. So that way, you have an idea of how long they're going to last in good conditions. Is there any questions? All right. So that's basically Vertex in a nutshell. If you're going on to college algebra, you definitely want to remember this because it will come up again. I'm going to stop the recording.